When it comes to color measurement, it is very important to know what the essential site parameters are. Every application is different, and a calibration is required to achieve application-specific goals in a specific environment. Unlike standard physical variables, color has no defined zero point. This means that a calibration for each application must be based on defined goals. For example, processing speed, color or CCT accuracy, CRI optimization, or the compensation of external influences. If you have problems in defining the right calibration procedure for your application, MAZeT's team of experts is glad to assist you with design and support for extensive simulation options. For now, this guide will explain you how to calibrate the MTCS-C3 colorimeter system. It guides you step by step through the process of calibration. Simply follow the installation instructions from the setup file. The software also requires to install the MATLAB runtime environment. MATLAB is a high-level language and interactive environment for numerical computation, visualization, and programming. This is used to provide the necessary computing power, for example for color coordinate calculations in various color spaces. Depending on the test software version, we use different runtime libraries of MATLAB. Please check our datasheets to install the correct runtime library. It is important to know that each application is different and therefore requires calibration. This method allows to eliminate external influences and improves the overall accuracy. Find an ideal mix between integration counter, reference current, and SIN period. The next steps will help you to improve your calibration setup. There are three main variables that need to be considered during a test setup during a calibration. These are the observer, the object, and the lighting conditions. When these three variables are known and optimized, the factor of gain in form of integration time and reference current depend on the light output and the environmental conditions. An ideal test setup where distance and the viewing angle of the sensor and spectrometer are equal is required. Make different tests to find an optimum between distance, object, light energy, and amplification. Make sure you have a stable test system and reduce environmental noise to a minimum. Reproducibility is an essential factor for a successful calibration. By changing the site parameters step by step, for example by changing the angle of incidence, one can test the setup and adapt to specific application needs without unknown interferences. You should know all influences before you start with the calibration process. This allows stable values and high accuracy. The software of the MTCS-C3 guides the user through the calibration procedure. Simply choose Calibrate within the menu or press the F2 button to set up a calibration process. With the ideal setup in place, the measurements can be performed by a 10 or 2 degree observer. The next step is to measure or import calibration targets. The user can choose the number of calibration targets and start with an offset, a dark measurement. The following step is to measure the chosen number of targets. After the measurements have been performed, one needs to import or enter the XYZ reference values measured by the spectrometer. A data file with a specific calibration information is saved and can be used for further reference. Changing elements, such as integration time or reference current, require a new calibration. If you don't have a spectrometer or reference values at hand, you can use a correction matrix that looks like this. After successful calibration, it is possible to use a spectrometer to perform comparison measurements. Using a color patch, simply perform measurements with the sensor and spectrometer to measure the current delta values. All measurements are logged and can be exported for future use. This is also an ideal method to test the accuracy and see if further optimization of the calibration is required or not. A further optimization of the calibration can be achieved by trial and error. Test different values for integration time, reference current, and divider. The software comes with a chart of possible parameters for gain times. This is a simple overview to show you what register values need to be chosen to correctly address the MTCS-C3 signal converter with your microcontroller. With an application-calibrated device, it is possible to measure values and compare them to reference measurements. You can freely choose your diagram type to show what color or ADC values have been measured. The reference measurements allow to determine the delta margin between two color points or measurements. Therefore, accuracy comparisons are possible. There are several diagram types to choose from. Keep in mind that the MTCS-C3 does not have an included illumination source. Therefore, it is ideal for self-illuminated objects such as TV screens, monitors, or displays. Aside the command mode, single-click measurements, there is the continuous mode. This allows to perform multiple measurements after another. It is able to monitor changes of color, CCT, or brightness in given applications. It is possible to turn off the diagrams to speed up the measurements. All measurements can be exported into Excel or CSV tables for further usage. If you have any questions or need support during your calibration process, contact us at any time. MAZeT's team of experts can gladly assist with design-in or other services, like calibration support, simulations, or optimization algorithms.